Hi students, welcome back to the class. Yesterday we have learned about acids and bases. While some of the compounds can act as both acid and base. Okay, so such compounds are known as amphoteric compounds. For example, water itself. Here you can see that one of the water molecule is accepting the proton, that is hydrogen ion, and another one is releasing the hydrogen ion. So it means what? Water can act as both acid as well as base depending on the conditions or with the other reactants. Now we have to see about the ionization constant of water and its ionic product. So let us see what this means. For that, first of all, we have to calculate the equilibrium constant for the above reaction. For that, you know that the multiplication of the concentration of the products. Here products are hydronium ion and hydroxyl ion, and below you have to put the reactant concentrations. Now the concentration of water is considered constant, and hence this is a constant and this is these are the constants. So two constants will merge up together and you will get another constant designated as Kw, equilibrium constant for the water, and it is equal to the concentrations of hydronium ion and concentration of the multiplication of both these two concentrations. Clear? Next, this hydrogen ion is made up of water and H positive. Okay, so when we talk about hydronium ion or H3O positive, we directly say that it is the concentration of hydrogen ion, because this is constant. Water, the concentration of water is constant, so the concentration of H3O positive means concentration of H positive. Now experimentally, it is found out that the concentration of hydrogen ion in the water is 1 into 10 to the power minus 7 mole, okay, molar at 298 Kelvin, the standard temperature. And also you know that water will release one hydrogen ion and one hydroxyl ion, so the concentration will be same. So for hydroxyl also it's 1 into 10 to the power minus 7 molar. Now putting the values here, you will get Kw equal to concentration of the hydrogen ion, as we have already said this equals hydrogen ion, okay, and concentration of the hydroxyl ion. So it will be 1 into 10 to the power minus 7 into 1 into 10 to the power minus 7, which means that 1 into 10 to the power minus 7 molar whole square. So if you use the exponential formula, you will get 7 into 2, so 10 to the power minus 14 m square. Clear? Now for acidic solutions, the concentration of H3O positive is greater than the concentration of hydroxyl ions. Okay, so this is in accordance with the Arrhenius concept of acid and base, which stated that those substances which can release H positive or hydronium ion are regarded as acidic solutions, and those solutions which will release the hydroxyl ion or OH ion, those are known as the basic solutions. Okay, so here in acidic solution, the concentration of the H positive has to be more than the concentration of OH negative. For neutral, it is equal, like water. In water, these two are equal, the concentrations. And for basic, it's the concentration of hydronium ion will be less than that of the hydroxyl ion, as you know that the base releases OH negative. Next, the topic is pH. You already know little bit about pH, right? So the proper definition for pH is, it is the negative logarithm of the concentration by mole per liter of hydrogen ion. So concentration by mole per liter, this term is designated as activity. So you can say it is the negative logarithm of the activity of hydrogen ion. Okay, and activity means what? We have written activity as A subscript H positive, okay, equal to concentration of the hydrogen ion divided by mole per liter, means in per liter how much of the hydrogen ion concentration is present. Okay, and pH is given by, according to the definition, it is the negative logarithm, so minus log of what? Of activity. Okay, so AH positive. AH positive is this, right? So you put the expression here. And what is the value of H positive? It's 1 into 10 to the power minus 7. So you can write 10 to the power minus 7, right? And this is one formula here for log x to the power a is equal to a log x. Clear? Here it will be 7 because minus and minus is there, no? So it will become plus 7 log 10. Okay, and log 10 value is 1. So ultimately you will get 7. For acidic solution, you know that pH is less than 7. For neutral solution, pH equal to 7. For basic solution, pH is greater than 7. Okay.